and talk about non-parametric tests now. So when we use non-parametric tests, it's because there's data that we have that isn't normal. It's not parametric, so it means it's not normally distributed. And so the different tests that we use are Mann-Whitney or the Wilcoxon-Rank Sum test, the Wilcoxon signed rank test, Kruskal-Wallis test, or Freeman's ANOVA. And so really the kind of the science or the math behind the non-parametric tests is that they rank data. And so again, you have to test your data for assumptions, and you use your non-parametric data tests when your data is not parametric. And so you have to figure out before you ever do anything if your assumptions are met or not. And if they're not, then you figure out what test that you can use that's not parametric. So we talked about last module how you can sometimes transform data, you can use log transformations, or you can bootstrap a few different things, but maybe you don't want to do that, or you have a super small sample size and the central limit theorem isn't going to be able to help you out. So you have to analyze the data in some way as it is, and so then you choose a non-parametric test. So the problem is that they make fewer assumptions about the data, and so sometimes you can lose information or you can lose power, and so you would have a type 1 or type 2 error. So several tests can be used to see if you have a normal data distribution. And this is what we did in module 3 with the Kolmogorov-Smirnov and the Shapiro-Wilk. So your null hypothesis is that you follow a normal distribution, and if you want to accept that, you want to follow a normal distribution. If you don't follow one, if you reject your hypothesis, then is when you have to do a non-parametric test. So with hypothesis testing, you can either have parametric tests or non-parametric. Again, parametric is when you have normal data distributions. So when it says z-test, t-test, those are the values that the statistical value that you get. So there's a t-test, but it's, independent samples, dependent samples. There's multiple kinds of t-tests. On the non-parametric side, there's a lot of other tests, but the ones that we're looking at include Wilcoxon and Kruskal-Wallis. I really want this graphic to really just show you that we're completely separating parametric from non-parametric, and within each of those categories, there's different tests to do. So the really good things about non-parametric tests is that you can use it with all scales. So you can use it with nominal, ordinal, ratio data, any kind of scale measures. It's easy to compute. You make fewer assumptions about the data. You don't have to think about the population parameters and include it in the analysis. And sometimes the results of a non-parametric test can be just as exact as parametric. The problems are that you can waste information because you're having to rank the data, so sometimes the information can get shuffled. And it's very difficult to compute by hand, which, we don't have to compute things by hand anymore, so that is still a disadvantage, but it's not something that's going to prohibit you from using the test. And there's not a lot of tables that you can use to look at, like you would see a z-score or a t-score table. If you have an h-score or something like that, you're not going to be able just to look in the back of a textbook and look at those tables. So the Wilcoxon rank sum and the Mann-Whitney test are non-parametric equivalents of an independent t-test. So this is where students often get caught up and a little bit confused, is an independent sample means that it's one group versus another, not a before and after. So like in the data set that we use, gender is a really good example of either you're male or you're female. And so if I test the blood pressure of males versus the blood pressure of females, then I'm doing an independent samples test because it's two different groups. I can't belong to both, and I have to identify as one or the other, and I'm testing them against each other. If I look at blood pressure over time, so I lump everybody together, males and females, and I say, okay, what was your blood pressure at 0 or baseline, and what was it after 3 months? That's a before and after. That's dependent. It's not independent. So when I want independent samples, I can use different groups, one group versus another, and the tests for that are the Wilcoxon rank sum and the Mann-Whitney. So when you rank data, your lowest score, you give a 1, and your highest score, or your next highest score, you give a 2, next highest score, you give a 3. And then if you have tied scores, you sum them together and get the mean. And so what this looks like, this is this chart. And so you see that you have the values here of 7, 5, 9, 3, 0, and 2. So what I'm going to do is take these values and I'm going to put them in order. So 0, 2, then 3, then 5, then 7, then 9. And that's what they've done here. So then I know that my lowest rank is 1. So I'm going to rank the 0 as a 1. And then I'm going to rank the 2 as a 2, and the 3 as a 3, and the 5 as a 4, because I'm ranking in sequential order. So 1, 2, 3, 4, 5. So you can see how this could get really complicated if you had, what if you had 300 participants and you were having to write out by hand and rank all of those? So if there's a tie, like here where you have 2 7s, then you get the mean of the mean of the rank. And so I have rank 1, rank 2, rank 3, rank 4. So I'm not going to rank this one as 4 or as 5. I'm going to say this is rank 4, this is rank 5. So 4 plus 5 is 9, divided by 2 is 4.5. And that's the rank I assigned to that data. So again, this could get really, really, really laborious if you had a lot of data to do this on. So the ones that we are concerned with in this class, the non-parametric tests, are the Mann-Whitney test, the Wilcoxon signed rank test, Friedman's test, and Kruskal-Wallis. So this is going to line up with your textbook very closely, because these are the same examples that Andy Field uses in your textbook. And so what this first study is a neurologist investigated the depressant effects of recreational drugs. They tested 20 people and then gave them a depression inventory. And so he said that you have to rank the data and don't pay attention to what group the person belonged to, just rank the data. And so if you're ranking this by hand, your Wednesday data, so I put all my scores in order, and I'm going to start with my lowest rank, which is 1, and then number them sequentially. But I see that I have 2 6s, which is a rank 3 and a rank 4. So 3 plus 4 is 7, divided by 2 is 3.5. So they both get the rank of 3.5. So if you were doing this by hand, this is what that would end up looking like. But you can use SPSS, and the first thing that he has you do is run exploratory analysis on the data just to even know if it's normal or not. And so this is the video that I was just talking about, that's in the assignments folder, or in the resources folder. And I think that you should probably watch it and go through the rest of this PowerPoint as you're watching it, because this YouTube video is about 40 minutes with Dr. Field going through this analysis and all the details that go into it. So I'm going to flip through this pretty quickly because he goes through every step detail by detail in SPSS. So this is showing you where you're putting your non-parametric variables, the output that you get, and what it's going to look like, and then showing you the Sunday data versus the Wednesday data. And so for those of you that might struggle a little bit writing a results section, this is what results look like. So what this is saying is that depression levels in ecstasy users, so the depression level in an ecstasy user was, the median score was 17.5, did not differ from alcohol users, and that median score was 16, or significantly differ. So there were differences, but not statistically significant differences. And then you can see here how the text looks when you have to report your analysis. So make sure that when you write your results section this week, that you start out with the just descriptive information about the sample, so 219 participants or however many there were, and they had an average systolic blood pressure of this, an average triglyceride of that. Whatever data you want to use to describe the sample should be like the first paragraph. And then the second paragraph, you actually write the information from the tests that you use. And remember that the results section is only the facts. So you tell me the facts and the numbers in the results section, and then you interpret that in the conclusion. So the tests that we just looked at were independent. So you're looking at groups that were not related. And it wasn't before and after data. It was ecstasy users versus alcohol users, or, men versus women, or young versus old. So you're looking at independent conditions. So now when we want to look at two related conditions, it's the Wilcoxon-signed rank test is something that we can use. And so these come from the same participants. And again, this is so important for you to understand, is that you have to use the right test for the right research question that you have. So if you're looking at between group differences, that's an independent sample. If you're looking at change over time or within group change, then that's a dependent sample, related conditions. And so this is more information from the ecstasy and alcohol group and showing you how to run that analysis. And so with your ecstasy users, you're looking at the depression level on Wednesday versus on Sunday. And so that's why you are able to use the same data, but do a completely different test, is because before you were looking at an ecstasy user versus an alcohol user. Now you're just looking at ecstasy over time or alcohol over time. And it still, he's going through these very, very good and very clearly in SPSS. So this is another example that Dr. Phil gives in his video about eating soy and sperm count. And so you'll see here that it's really interesting because now there's multiple groups. There's not just two groups, there's a lot more than that. And so this is how you would rank out the data if you did it by hand. And so again, very onerous to do this and do it correctly. And so we go through the exploratory analysis, the actual analysis in SPSS, and it depends on if you have a Windows or Mac, and what version SPSS you have, exactly what all these choices look like. And so with the Kruskal-Wallis test, it just tells you that you have significance or not. And that's it, period. And so once you find that out, you have to go back through and do separate analysis to find out where the actual differences were. And so this is just like an ANOVA. And so again, he's explaining this step by step in that video. And so this is an example of how to write the results up from the Kruskal-Wallis test. And then you have to do the follow-up test, because just telling me that there's a difference doesn't really help me at all. I need to know where those differences are. And so Friedman's ANOVA is a way to test between more than two conditions, and it's based on rank data. So this is another example in that video where he's talking about the Andikins diet, and you're looking at 10 women over time. So this is what the rank data would look like. And if you had more than 10 people, it would be a lot of work to try to get that separated out. And so these KS and the Shapiro-Wilk tests are telling you that if your significance value is greater than 0.05, then what do you know about that information? So it's not significant for the initial weights at the start of the diet, so the weight at the start, but the more accurate Shapiro-Wilk test is significant. So you have differences here, even though you're using the same data. Based on the test, you have different results. And then the data at the end of the diet weren't different in either one. And so now you can see your Friedman ANOVA, and when you have an ANOVA that is not significant, so like this 0.905, you retain the null hypothesis. It says that their weights are the same. There's no reason for you to need to do follow-up tests or post hoc tests because you know there's no difference. And so it would be a waste of time to do those follow-up tests. And so this is an example of how you would write those results. So if you have non-parametric data, then the 4 tests that we're concerned with are the Mann-Whitney or Wilcoxon rank sum, the Wilcoxon signed rank, the Kruskal-Wallis, and the Friedman's. And so with Mann-Whitney, you're looking at 2 independent groups of scores. So that means that you're just looking at males or females, or 1-year-olds versus 2-year-olds. So you're looking at 2 independent groups of scores at one point in time. The Wilcoxon signed rank test, or you're looking at 2 dependent groups of scores. So one group or one time depends on another. So like if I'm on a weight loss trial and I measure myself at baseline and at 3 months, my change is going to be relative to my BMI at baseline. And so I can't do independent groups test. I have to do dependent because it depends. My 3-month results depend on my baseline. And then the Kruskal-Wallis compares more than 2 independent groups of scores. So the Kruskal-Wallis is perfect for BMI categories. So you have underweight, normal, overweight, and obese. So you have 4 categories so that's a really another interesting thing to think about, because BMI, body mass index, is a continuous variable. You can have anything from, a 12 BMI to a 60. And so what we have to do is say, okay, if you're underweight, you're going to have a BMI of 18 or less. And if you're normal, you're going to have a BMI of 19 to 24. So we put these people in categories, and so that's how we group them. And so if I wanted to look at the difference in blood pressure between people who have an underweight, normal, overweight, or obese BMI, then that would be a perfect example of when I could use a Kruskal-Wallis test. And then the Friedman's test looks at more than 2 dependent groups of scores. So maybe I want to look at BMI in over 4 time periods. So baseline 3 months, 6 months, 9 months. So I'm going to look at the BMI for everybody in my group over those 4 time periods. So you have the M4 data set, and I want you to conduct 2 different non-parametric tests. So you choose between any of those 4 tests and run them on the data set. So an example was I chose the Mann-Whitney and a Wilcoxon because I wanted to do one that was independent and one that was dependent. And so now I have to choose my variables. And so I don't expect that you'll do all the assumption testing because I'm telling you that these variables are non-normal. So just go on and do the non-parametric test. So I chose the Mann-Whitney Wilcoxon rank sum test. So let's go over to SPSS and check that out. And so this is my data set, and there's a few more variables than last time, but what I want you to be particularly aware of is what these variables mean so that you know how you can pick out your own tests. So BMI as 0 is BMI at baseline, BMI 1 is at 1 year, BMI 2 is at 2 years. So the 0, 1, and 2 are at different time points. So it's the same thing for systolic blood pressure, for total cholesterol. Age is continuous. So we just asked them what their age was, and they told us a raw number. Race, I can go here and see that I have 5 different races to choose from. And then school level, I have a ton of different school levels to choose from. So 9 different levels that I can choose. And then marital status, I have 5 different marital statuses. So these are groups. And then with my income, they're also grouped. And so I can do 12 different income groups. Money spent, so the money spent on the supermarket, money spent on eating out, those are just raw numbers. And then the heard of my plate is, we asked them a question and it says, have you ever heard of my plate? And 1 was yes and 2 was no. So, it would be really easy to do a study or analysis where you use those as your groups and did an independent test to look at maybe the total cholesterol at baseline between people that had heard of MyPlate and people that hadn't. So this is, have you ever looked up MyPlate on the internet? Have you tried MyPlate? Have you looked at information on the fast food menu, on restaurant menus? And so these are the ones that are particularly helpful. General health conditions. So are people that have poor health more or less likely to have a low BMI or have a high BMI? So think through what questions you can ask, and you can use any of these variables that you want. Okay, so I said that I was going to do the Mann-Whitney-Wilcoxon rank sum test. So I have to go to Analyze, Non-Parametric Tests, and I knew I want independent samples because I wanted that Mann-Whitney. So I'm going to choose my independent sample, and it brings me to this. Well, I had already done it. So let's look at systolic blood pressure at 0. And that's my continuous, and so my test field, but I want to look at it as independent, so I have to choose something that has groups. So I'm going to choose gender and move that over there. And so if I run my test, I get this simple little hypothesis test summary that says my null hypothesis was that the distribution of systolic blood pressure is the same across categories of gender. So what that says is that regardless if you're male or female, you're going to have a similar blood pressure, systolic blood pressure. I used the Mann-Whitney, and it gave me 0.758, so I know that I retained my null hypothesis. So that means there is no difference across males versus females. So something that can help me is to go back over here and do just my basic descriptive statistics. So if I want my frequencies, and then I'm going to move gender over here, and I'm going to move systolic blood pressure because those are the only ones that I use. And I want to check if I can get means, standard deviations for those, just all that right now. Okay, so let's see. I have 87 males and 182 females. So that right there tells me a lot about these results, that there's not equal sample sizes. So that's something that I can talk about in my conclusions, is one of the reasons why I might not have seen any significance is because the sample sizes were unequal. Okay, so let's go back over here. So I retained my null hypothesis. So the next thing is I'm going to choose my Wilcoxon signed rank test because I want to look at change over time. So let's pull that back up. And I want to look at systolic blood pressure at 0 and systolic blood pressure at 1 year. So I'm going to analyze. I'm going to do my non-parametric, but I know that I want related samples because I'm doing dependent samples. And so I'm going to put in my 2 blood pressures. So you just hit control and select them and move them over. And I could even move this one over too if I wanted to, but let's just stick to this right now where it's simple. I'm going to run that. And so my null hypothesis is that the differences between systolic blood pressure at 0 and at 1 are the same, equals 0. So my significance is 0. So that means I can reject my null hypothesis. So that tells me that there are differences between 0 and 1, but I don't know what those differences are. So I have to go back to my data set and I have to do analyze descriptive statistics, which you really should do this first before you do anything else ever. You always want to get your descriptive statistics. And so descriptives, I want to know what those blood pressures were at 0 and 1. And so I have 269 people that came to baseline and 227 people that came at 1 year. So that's the first paragraph of my results section right there, is that 229 people were assessed on blood pressure at baseline, and then 227 came back at 1 year. And so I can see that with the minimum, these are the lowest blood pressures, and the maximum are the highest blood pressures, which that's really scary that they were walking around driving 180 and 190 systolic. But anyway, the mean or the average blood pressure at baseline was 125.99. And the mean at 1 year was 120.27. So I can see that I reject my null hypothesis. So I know there are significant differences. So thank goodness it went from 125.99 to 120.27. So I decreased my blood pressure in my entire sample over time. So it took me a year to decrease that blood pressure. Okay, so what I want you to do for your assignment this week is to ask your questions and choose your variables. So your variables need to be different than the ones that I've used. And I want you to use that M3 example write-up to be able to write up your results and conclusions. And so you should use the comments that I give you back on your M3 to make M4 fantastic. So if I see that you're ignoring my comments or my track changes, then we're going to need to talk about if you know how to use comments and track changes. So if you don't know how to use them, please call me, email me, or YouTube that, or put it on the discussion board and get people to tell you how to see comments and track changes. It's super important that you read all through the comments and fix those mistakes, because sometimes you'll be able to just copy and paste a little bit of your methods section or a little bit of your introduction into the next week's assignment. And if you continue to use the wrong one or the one with the mistakes, then you're going to continue to get points counted off. And so again, I want to talk through this data set because some of you are not in healthcare and may not know, what it means to have high blood pressure, high cholesterol, those types of things. So that was really the point of the introduction last week, was to get you to look up, even if it was on mayoclinic.com, to see what body mass index was, to see what blood pressure was. So you need to define those things and figure out what's good and what's bad. And so if those don't excite you and you just don't really want to talk about BMI, blood pressure, or cholesterol, then you can look at groups like household food security and the general health, sedentary activity. So that's minutes of time that people reported just sitting around watching TV. And then they actually we have a categorical variable where they tell us how many hours of TV they watched the past 30 days. And then how many times or how many hours they use the computer in the past 30 days. So if you wanted to do an independent test, then you could use this with your 4 groups or 5 groups to figure out if there's a difference in cholesterol over these groups of people. And so when you do something like that kind of test, you do have to have a continuous variable. So you could do, is the hours watched of TV significantly different, or is the minutes of sedentary activity significantly different between groups that watch different hours of TV? So if you have questions about this data set or you're not really sure how things fit together, just let me know. Okay, so I want to show you an example really quick of a assignment here. So you would start out with changing your title to non-parametric models, because that's what you're working on this week, and then you write a few sentences about what non-parametric models are, why you're using them, and then you use your whatever variables you use, you're going to select those and use that as your introduction. So you have your research questions, so you need to identify what your research questions are, how you selected those variables, and then what statistical tests that you did and why you explain why you chose those tests. And then your results section. So you need to make sure that you have your APA table in there, and you have to do your descriptives of the sample for the variables that you're using. And then you talk about linearity and normality of your residuals, and then each of the tests. So those are your assumptions testing. And then Mann-Whitney test and Wilcox and assigned rank test are the ones that were chosen here. And so that's as simple as it needs to be. And then you write your conclusions about what you found in those tests. So if you have any questions about how to write up that module, just let me know. And let's see, so you have your discussion. So you're going to do task 2 on page 248, and that data set is uploaded already. You have your quiz and your assignment. And so we're halfway to midterm. And if you need any help with your assignments or anything like that, please don't hesitate to reach out to me. And good luck this week.